3. Perception of certain aspects of life have changed since ancient times. One of these aspects is the perception of the atom. From 420 BCE to 2018 modern times, models of the atom have been made and changed. Each model is changed by a remarkable scientist every few centuries. The models have certainly improved due to technological advancements and will continue changing. One of the first scientists to contribute to the atomic theory was Democritus, and he lived from 460 to 370 BCE. He was also labeled the laughing philosopher. He discovered that everything is composed of atoms, and atoms are physically, not geometrically, invisible. According to websites, Democritus knew that if he cut a stone in half, both would be made up of the same components, that they wouldn't change. After making that realization, he found that if you keep cutting the stone into smaller pieces, the pieces would eventually be so small that they would become invisible. Therefore, he called the smallest piece atomos, which we now call atoms. This is important to the structure of the atom because it is the foundation on which other scientists build their own predictions and research on. If we didn't have Democritus' discovery, the idea of the atom wouldn't be as accurate as it is today. John Dalton was born September 6, 1766 and died July 27, 1844. Dalton's atomic theory was he used Democritus' theory and created a solid foothold. He stated all matter are made of atoms that are invisible, and all atoms of a given element are identical in mass and properties. Compounds are formed by a combination of two or more different kinds of atoms. A chemical reaction is a rearrangement of atoms. His atomic theory was an important contribution to the atomic structure of an atom because it further explains the atom. It explained that elements don't change even when they turn into something else. From his atomic theory, he came up with the law of conservation of mass. This law states that matter isn't created or destroyed in a closed system. When there is a chemical reaction, the amount of each element has to be the same in the starting compound and the ending compound. The number of atoms does not change when a chemical reaction occurs, and the total mass of products will always be the same mass as the total reactants in a chemical change. This law is important because it explains that no change happens with the atom even after it goes through a chemical change. J.J. Thomson, born December 18, 1856, and died August 30, 1940. He made the cathode ray tube. The basic setup was two metal plates inside of a glass tube, and the negative side of the metal plates was called the cathode, and the positive side was called the anode. Cathode rays are what they called the cause of the dark spots on the glass tube formed on the cathode side. Many scientists experimented with cathode ray tubes but did not get results until Thomson. During his experiment, he let his cathode rays travel through the air and saw that they traveled farther than he thought they would. This told him that cathode rays are actually smaller than scientists thought atoms would be. He deflected cathode rays with electric and magnetic fields. From this he found out cathode rays are negatively charged. Particles in cathode rays are 1,000 times smaller than particles in a hydrogen atom, and this was the discovery of an electron. This experiment led to the discovery of electrons. Without this discovery, the scientific community would not have been able to advance and come up with a representation of an atom. He also had the plum pudding atomic model. This model was made when Thomson was eating plum pudding. He stated that negatively charged electrons, or plums, are mixed with positively charged electrons, or pudding. This was basically the discovery of the nucleus of an atom, negative charged electrons that are moving within a. The importance of the plum pudding model shows the correlation between negatively and positively charged protons. This shows that there are smaller parts of the atom. Ernest Rutherford was born August 30th, 1871 and died October 13th, 1937. He did the gold foil experiment. He was studying the effects of X-rays on different metals before he could study the effect of particles on matter. He had to figure out a way to count individual particles. To count all the particles, he found that a screen coated in zinc sulfide flashes a light each time it was hit by a particle. So they sat in the dark to count how many flashes it emitted. He saw that the particles passed through the piece of foil. The beam was broadened. Gold can be turned into a thin foil, so as the beam passed through the foil, the scattered beams were small. He expected that the particles would pass through the foil like a bullet would go through the bag of sand, but instead the beam bounced back at them without going through the foil. He concluded that all the positive charge and all the mass of the atom is concentrated in a small part of the entire volume of the atom. He called it the nucleus. The importance of this was that the gold foil experiment discovered a whole new part of the atom. It found that the atom had a center called the nucleus. He also had the Rutherford model. After he conducted his gold foil experiment, he came up with his own idea as to what the atom looked like. He published his model to the scientific community, and they found an error in his model. Bohr noticed that there was nothing keeping the electrons from orbiting into the nucleus, and Bohr later fixed Rutherford's model. The importance of this was that because without it, Bohr would not have been able to correct it and come up with a more accurate representation of the atom. Niels Bohr, born October 7, 1885, and died November 18, 1962. He did the Bohr planetary model. The model was proposed in 1915, and it was a modified Rutherford model that required that the electrons move in orbit or of fixed size and energy. It refined certain elements of Rutherford's model that were problematic. It included the problems arising from classical mechanics, which predicted that electrons would release electromagnetic radiation while orbiting a nucleus. In the loss in energy, the electron should have rapidly spiraled inwards and collapsed into the nucleus. It is important because it proved to be groundbreaking in some respects, and it was also useful for predicting the behavior of electrons and hydrogen atoms. Bohr's model remains useful and an instructional tool for introducing students to more modern theories, such as quantum mechanics and the valence shell atomic model.